Hey everyone, my name is Alyssa Sinaway. I'm an architectural specialist here at ARDEX. I just wanted to take a minute to say thank you for joining us for today's Learn from Home webinar. In an effort to stay connected during this time of social distancing, we will host a webinar every Thursday at 2 p.m. Eastern Time. Today's presentation is AIA certified and will count for health, safety, wellness credits, although you don't have to be an AIA member to participate. Please note that the certificates for today's webinar will be distributed by email early next week, and if you provided an AIA number during registration, we will report the credits on your behalf. Next week, we will feature a course on designing installation systems for gauged porcelain tile panels, and the week following, we will feature a special guest speaker, Mr. Peter Craig, holding a Q&A session on moisture in concrete and early phase concrete management. We invite you to submit questions for Peter by next Thursday, April 23rd. Feel free to submit today during the webinar to me by email or via the SurveyMonkey link in our most recent webinar announcement email. If you have any questions on this, please feel free to reach out to me by email as well. In today's presentation, we will be covering adhesives and navigating high relative humidity. This is a brand new CEU course created to address one of the biggest issues in flooring today. This is also the first time this course is being offered anywhere, so thank you for being part of our inaugural class. I'm going to go ahead and turn it over to our presenter, our Director of Technical Services, Mr. Seth Pavarnik. Seth has been with ARDEX for almost 20 years and has worked with many industry organizations and standards committees. He'll be hosting a Q&A portion at the end of the presentation, so feel free to submit your questions as the presentation progresses. So Seth, go ahead and take it away.
Thank you, Alyssa. And thanks to everybody that's joined us this afternoon. We appreciate you taking some time out of your schedule to spend some time with us. You'll see on the first slide here what we're going to cover today. So chemistry of adhesives, basically, you know, what goes into an adhesive. We'll go through all the different constituents so you have an idea there. We'll look at types of adhesives that are out there, you know, your acrylics, epoxies, urethanes, latexes, things like that. We'll look at some of the factors for successful installation. Moving on into problems due to moisture in concrete and what those things look like. We'll look at the different sources so we understand, you know, where the moisture is coming from that's causing the problems. Move into testing. And then from there, we'll look at how RH as well as pH impacts the installation. We'll finally review a condition that I want everybody to understand pretty thoroughly that is a result of excessive moisture in concrete, and that is slab curl relaxation. And then we'll kind of wrap things up, just making sure everybody understands the need to remediate excessive moisture in different instances. So a snapshot here in the flooring industry here, the adhesive industry. Environmental regulations, regulatory changes have demanded formulation changes for many adhesive manufacturers, eliminating goods that may be health or environmentally hazardous. The main thing here would be the solvents in the adhesives. You go back to the, you know, the 80s and earlier, and in the early 90s, you had, you know, the solvents in the flooring adhesives, which were, you know, kind of moved out into the 90s, into the waterborne technologies. And then flooring changes are another issue for adhesive manufacturers. The structures were typically PVC, but they're being replaced by polyolefin backings, fiberglass backings, recycled materials. That's the big one these days, and it makes it difficult for adhesive manufacturers. You know, no longer can we just make a single adhesive for a variety of different, you know, vinyl back floorings. In a lot of cases, we do have to test specifically due to the recycle content and the different backings. So looking at the chemistry here, just so we understand, and when I say chemistry, it's basically all the constituents that make up an adhesive. So we'll start with a binder, And that's basically the material or the base polymer that's basically holding everything together. So it could be an acrylic, for example. You know, that binder is what's holding the floor covering to the substrate. Also within the chemistry, you have petroleum processing oils as well as resins. And these are materials that are added to the adhesives that will soften the polymers and in some cases enhance the dry tack. So when an adhesive goes to a dry, pressure sensitive, for pressure sensitive installs, you have a degree of tack there, and that tack is achieved by the different processing oils and resins. There certainly are preservatives and fungicides in the adhesive, and that basically stops things from growing, stops bugs from growing in the pail of adhesive. You know, what I don't want you to misunderstand is, you know, once an adhesive is cured and you're in a situation where you have moisture in a food source, that preservative or fungicide that's in the adhesive is not going to prevent that type of you know, mold or bacteria from growing. You know, this is just in the pail of wet adhesive. Now, there's also fillers in there, such as clay, carbon black, calcium carbonate, silica, and I don't mean silica sand. It'll be like a silica flour or a silica powder. And the calcium carbonate currently used as a filler. It's used in cement materials. I want you to remember that. I'm going to circle back to that at a later point in the presentation. There's also rheology modifiers, basically thickeners, depending on what you want out of an adhesive, how the adhesive feels when you're trialing it out. Certainly, if we're using an adhesive to hold a piece of wall base on the wall, we want a certain viscosity to it, slightly thicker adhesive so that it has good, you know, good grab or good wet suction. There's also antioxidants that are put in the adhesives to prevent, or I shouldn't say prevent, but to retard oxidation. Adhesives can oxidize over time. Some adhesives, I should say, and we'll kind of get into that in a little bit. There's also light and heat stabilizers in the adhesive. In some of these applications, you know, it might be a sliding glass door or a wall of windows where you have ultraviolet light coming in. You have the sunshine coming in, you know, with the heat. You also have the adhesive, you know, itself that is, even though it's underneath the floor covering, it's effective in some capacity. So there's different constituents in there to help with that. There's cross-linking and vulcanizing agents in there that help aid in the curing and the chemical bonding or the chemical reactions of the adhesive. And even if it's a single component material, the chemical bonding of that single component of adhesive to the floor covering itself. Okay, so moving on from the constituents that are in the adhesives, let's look at the adhesive family tree here, the different types of adhesives. So going from left to right, we have solvent-based, then we have water-based. And you'll see that I have in parentheses born. And the industry references these products as solvent-based or water-based. It's a little bit of a pet peeve of mine because technically the adhesive isn't based on water or based on a solvent. It's based on a chemical or a binder like an acrylic or a latex. It's born with water. So technically it's a waterborne adhesive, but or a solvent-borne adhesive. But you know, I have the water-based or solvent-based in there because that's just how the industry references these materials. You also have urethanes, both one component and two component. And you have epoxies, which are two component. And then with the water-based technologies, which is more present day, we have rubber resins, the styrene butadiene rubber, latex resin products. These are synthetic latex, not natural latexes. And then you have acrylics, and the newer technologies of present day are primarily acrylics. And we're going to go through these individually. So let's take a look at how a solvent-borne adhesive works. So you have, you know, the binder, which could be a latex, like I had just mentioned, an SBR latex. And then there's different solvents in there. They could be hexane or naphtha or toluene, 1,1,1 trichloroethane, and so on. And basically the solvent's the carrier. The solvent helps get the resin or the binder, such as a latex, to the floor. And then as the solvent flashes off, it allows the latex polymer to coalesce and then bond the flooring to the substrate. So the solvent is only the carrier, helps get the binder material, the latex, for example, to the floor. Some of the advantages of solvent-borne adhesives, some of these can provide very high early strength. I'm aware of an adhesive, a solvent-borne carpet adhesive for outside, and the solvents that are used flash off so quickly that carpet adhesive could be put into service in like 2 hours. You could get rain on it within 2 hours. That's one of the advantages of a solvent-borne adhesive. You also have a variety of open times depending on what solvent you use. You have something like acetone that flashes off very quickly. You have a very short open time. There's other solvents that take longer to flash off, petroleum distillates and others that give you a little bit longer open time. Sometimes the solvents can easily wet out difficult backings, difficult surfaces there. And also, compared to a waterborne adhesive, we're not dealing with water evaporating out of the adhesive with the solvent. We're dealing with a solvent evaporating out. And the higher humidity, is not so much affected with the solvents because they can emit through the floor covering. And it's not like water that has to be drying here, and it's difficult in between two impervious surfaces. The solvent flashes off in high humidity and through the impervious floor covering. Some of the disadvantages, they're pretty obvious here, the flammability and the toxicity from a transportation standpoint, and especially from a use standpoint. Flammability and toxicity for the guy installing, the installer that's using the adhesive. Certainly with the aggressive solvents, you have strong odors, and you certainly have high VOC levels, the volatile organic compounds. All right, so let's look at a waterborne adhesive and how it works. So similar to the solvent-borne, you have a binder, which could be a latex, could be an acrylic, and then as opposed to having the solvent as a carrier, you have water as the carrier. So the water helps get this acrylic, this latex to the floor, and then once the water starts evaporating out of it, the adhesive binder material, the acrylic, the latex starts coalescing together and then forms a bond, to the floor covering itself and the substrate beneath it. Some of the advantages of the waterborne chemistries out there, low or even no VOCs, no volatile organic compounds. They're non-toxic, non-flammable, and in its wet state, the adhesive can be cleaned up with soap and water, whether you're cleaning your tools up or you happen to get some adhesive on the flooring or a wall, can be cleaned up while it's wet with water, soapy water, okay? Some of the disadvantages, a little bit more dependent on temperature and humidity. If we have high humid conditions, it makes it difficult for an adhesive to dry. Keeping in mind though that your floor covering manufacturers recommend these floorings be installed in acclimated spaces, how the space is going to be used. Okay. Generally speaking, the waterborne adhesives cannot be used in between two non-porous surfaces. Many of the waterborne adhesives require a cementitious layer underneath of it so that the moisture from the glue can go into that cementitious substrate, whether it's concrete or a patch or leveling material. Now, having said that, there are some technologies that can be used in between two non-porous surfaces. They may require a smaller notch trowel. They may require a little bit longer opening time, meaning letting a little bit more of the water evaporate out of the adhesive before you drop the floor covering in. But ultimately, these recommendations have to come from the flooring manufacturers and the adhesive manufacturers. Okay. Another disadvantage is the freezing aspect of it. A lot of the newer technologies that are waterborne, they can handle a couple of freezes to certain temperatures before they're adversely affected. But you got to check with each adhesive to see what its requirements are and what its restrictions are. Okay, so out of the waterborne adhesives, the first one we'll talk about here is an SBR. That's a styrene butadiene rubber emulsion, also classified as a latex adhesive. Some of the advantages with this type of resin, there's a wide range of SBR polymers to choose from, meaning depending on what you want that adhesive to be used for, there's a lot of versatility there. And with a wide range of polymers and good supply, it ends up being pretty economical. And they're pretty high performing materials as well. Some of the disadvantages of the SBR polymers is some of them oxidize over time, some more so than others. Some require, a significant addition of antioxidants in the formulas to help preserve that oxidation process so that you get good life out of that adhesive. Some of the SBR polymers, I should say most of the SBR polymers, can be susceptible to plasticizer migration. Plasticizers are added to resilient floor coverings like your vinyl floor coverings. Whether they're solid vinyl, either homogeneous or heterogeneous, these plasticizers are added to make the vinyl products more pliable, more workable, more user friendly. The problem over time is these plasticizers can migrate out of the floor covering and they can affect the adhesive if the wrong adhesive was used or if the adhesive was not designed to have good plasticizer migration resistance. So generally speaking, your SBR latex adhesives, they typically don't resist the plasticizers that much. Your acrylic adhesives, on the other hand, typically have real good plasticizer migration resistance. Some of the disadvantages here in more recent years is the costs are rising in the SBR polymers due to the availability or lack of availability. From there, we'll go on to acrylic adhesives. These are your newer technologies that you see present day for your solid vinyl tower plank, solid vinyl sheet, your vinyl carpet back, vinyl backed carpet. These acrylic adhesives are typically used with those different flooring structures. They have a very good resistance to plasticizer migration. They have very good strength properties and perform well over longer periods of time. You'll see some of your newer acrylic adhesives have a lot longer warranty on them because they just perform longer. Some of them go up to, a lot of them are 10 years, some of them go up to 20 years from a performance standpoint. The disadvantage, these newer technologies, they're higher cost. We'll move on to urethane adhesives. These can be one component materials that use moisture to cure the adhesive. And then some of them are two component where you have an A mixed with B and a chemical reaction between the two. These are very high strength. Sometimes they can be too high, not so much present day, but some of the older style urethane wood adhesives tended to be a little bit too high strength. You commonly see urethanes used for adhering wood flooring, engineered wood plank, and wood moves with traffic and moisture, changes in temperature, humidity, and some of these adhesives of yesteryear were a little bit too strong and couldn't move with how the wood flooring and the wooden subfloor was moving with foot traffic and changes in temperature and humidity, and contributed to problems. Commercially, you'll see two component urethanes where you got A reacting with B. These are high performance adhesives, have excellent bond, indentation resistance. You'll see these used in your high dollar medical equipment rooms and applications like that. Epoxies, which are kind of similar to the two-component urethanes, they're just a different chemical base, but they have a lot of similar performance properties. Very high strength. You got A mixed with B, and they're chemically reacting between the two, and very commonly used in the high-dollar medical equipment rooms, or maybe in the patient rooms in hospitals where you have the striker and Hill-Rom beds with the point loads and the rolling loads. With normal adhesives, those types of point loads and rolling loads can displace adhesive and cause indentation. And epoxies and urethanes, the two-component adhesives, are a lot higher strength and they resist that type of point load and rolling load. To give you an idea on how the evolution of adhesives has gone over the last 100 years, you go into the early part of the 1900s and there were paste adhesives out there, waterborne pastes. And from there, we moved into the solvent-borne adhesives, asphaltic adhesives that had solvents as the carrier, you know, from the 40s, 50s, 60s, 70s, 80s. You know, the most widely known and understood solvent-borne asphaltic adhesive is cutback, the black mastic. They call that cutback because years ago they used to cut it with gasoline to thin it out to make it used as a flooring adhesive. That's how it's got its name, cutback. But you know, with the aggressive solvents, the flammability, the toxicity, back into the late 80s, early 90s, we saw everything transition to waterborne materials. No more solvents, low VOC, installer friendly from the standpoint of you know, the flammability and the toxicity. You know, you don't have that with the waterborne technologies. Moved into wood, the wood installations moved into moisture cured urethanes into the 90s and the waterborne adhesives into the 90s. I want to review just quickly here, not to spend a whole lot of time on this, but some of the adhesive installation considerations, just so we have an understanding of the different terms used during application and some of the service conditions and things about the floor covering itself, so that we have a true understanding. But open time, that's from an application standpoint. You pop the lid, you pour the glue out, you comb it out, and you may have to let it sit there for 10 minutes, 15 minutes to allow some of the water to evaporate out or flash off, and that's called open time. Working time is basically once you drop the floor covering into the adhesive, you have a certain amount of working time to adjust it and move it before that adhesive has, you know, permanently bonded that floor covering. There's three different types of adhesives. You know, I realize, you know, when I say type of adhesive, you may be thinking an acrylic or a epoxy urethane, you know, solvent-borne material. But when we say type of adhesive, maybe application method might be a better detail there. You have the wet set application method, meaning we pop the lid, dump the glue out, comb it out, we drop the flooring in immediately, or maybe just after you know, 5, 10, 15 minutes of open time. That's called a wet set. Then you have what's called a pressure sensitive application method, and that's when you apply the adhesive, whether you comb it out, roll it out, but you let it go totally dry to the touch, to where you put your hand in it, you don't have any adhesive transfer to your hand, and at that point we drop the flooring in it. That's a pressure sensitive install. And then there's transitional, which is somewhere in between a wet set and a true pressure sensitive. So it's not truly wet, but it's not dry to the touch, and that's what's considered transitional, sometime in between. And then you have the application method, how the adhesive gets to the floor. Certainly trial applied, been done for years. Newer technologies allow for spraying the adhesive down, letting it go dry to the touch, dropping the flooring in, and then you also have roller applied. Things to keep in mind are the service conditions, you know, when selecting a floor covering and selecting an adhesive, especially an adhesive, the rolling loads, the type of traffic over it, the point loads, you know, may distinguish whether we're going to use an acrylic or maybe a two-component epoxy or a urethane. Certainly chemical exposure, your service time, when you want to get that floor turned over. I mean, there's some roll-on adhesives that as soon as they go dry to the touch, you can drop vinyl tile or plank sheet into it, and you can open up to a traffic immediately. In other cases, some of the wet sets might be a 24-hour wait time. And then, certainly maintenance, how this floor is going to be maintained. We got to take that into consideration. When selecting an adhesive, we also got to look at the flooring. I told you earlier, a lot of the, structures now have moved from PVC to polyolefin to recycled. And we have to understand what those backings are and the dimensional stability. The geometry of the product's very critical. Small tile like 12 by 12 VCT are pretty easy, but you get into 24 by 24 LVT or even some of the LVP that are a lot longer than that. You need the right adhesive to hold that in place. Certainly the orientation, whether it's machine direction or the cross direction's got to be taken into account. And certainly the susceptibility of telegraphing of the substrate too. Some other installation considerations to look at, certainly the flatness and smoothness, depending on what floor covering and adhesive you're selecting, that's got to be taken into consideration. Okay. Certainly the porosity. As I said earlier, a lot of the waterborne adhesives require a cementitious material that has a degree of porosity there. If you have a epoxy mitigation system down, a lot of the adhesive and flooring manufacturers want an 1/8 inch of a cementitious blotter layer, so that waterborne glue has the water in it can go down into that porous surface. Okay, we obviously need a clean, dry, contaminant-free surface to start spreading adhesive and install floor coverings, and certainly moisture with the alkalinity that goes along with the moisture is critical too. If we have excessive moisture and high alkalinity, that alkali can attack the adhesive. It can emulsify the adhesive, and if the adhesive doesn't have its integrity anymore and it's emulsified, then certainly disbonding is going to occur. So with excessive moisture, pH is very critical, and we're going to spend some time talking about pH too. So before we get into that, we're going to look at some of the problems due to moisture, the sources, and then ultimately testing. But the reality here is billions of dollars are spent each year because of flooring failures as a result of excessive moisture. The bottom line is an otherwise perfect installation will fail if moisture issues aren't addressed. Okay, so we have to test for moisture. We have to remediate the excessive moisture to have that flooring and adhesive perform as it was intended. So why do we see so many problems now? Number one, we see conversions out there in the industry. It used to be a warehouse. Now we need to make a portion of this warehouse into offices. And, the warehouse, it really didn't matter, whether we had excessive moisture emitting through the concrete slab, because it was a warehouse floor. It's concrete. There's no sealer on it. There's no vapor retarder underneath, but really, who cares? Moisture can just come up through the slab and emit into the air, and it evaporates. No harm, no foul. You can close that area in and put flooring down, turn the HVAC on, and now you got vapor drive, and it can cause issues. Certainly, fast track construction is why we see more issues present day. You dig a hole, pour a foundation, pour walls and a roof, and 30 days later they want this open for business and get return on their investment, and they're quite simply not allowing the concrete a significant time to dry, sufficient time to dry. Additionally, at one point in time, the concrete slab construction practices changed to eliminate the vapor retarder. So there's a lot of those slabs out there that just don't have a vapor retarder. Okay, and really, we got a lot more of an understanding and awareness to moisture issues. Years ago, you go back 30 years ago, and there could have been a failure due to moisture, but everybody just looked at the flooring that looked terrible and said, installer must have screwed it up. So we got a lot more knowledge present day. We have a better understanding. Problems due to excessive moisture. Okay, excessive moisture, along with pH, can destroy flooring adhesives. So we get to condensed liquid underneath the flooring structure, and we realize at that point what the pH is, and that high pH solution can basically liquefy or emulsify the adhesive, as you see in the pictures here. Another picture of it here. So, if the condensed liquid underneath the flooring, along with the alkalinity of the concrete, is a reality, it can break down or emulsify the adhesive. If the adhesive emulsifies, it's going to begin oozing between the joints. The result is, flooring's not bonded anymore. Okay. Things can start to grow underneath the flooring if we have a food source and some moisture. Those things that start to grow can stay in the flooring. Okay. All these things is a reality of excessive moisture and alkalinity. Also efflorescence, and we're going to table efflorescence right for now. We'll come back to that here in a future slide. But efflorescence is a process or function of excessive moisture. So there's many different sources of moisture. I don't know if you can see my cursor. Hopefully you can, but I'm pointing to the concrete truck. Certainly the mixed water in the concrete is a source for moisture. We put a lot of extra water in the concrete so that it can come down the chute. We can screed it, float it, finish it. And that excess water's got to evaporate out. And that's the reason we can't put flooring on it for 2-3 months, sometimes a year, because we got excessive water coming out of the concrete. But there's other things, irrigation or planters on the outside of the building that can drive moisture into a concrete slab. How do we have a moisture problem on the 23rd floor of a slab in a building? Maybe it's a broken pipe. Okay. Maybe it's a topical moisture problem where you got the guy mopping the floor, just slopping water down, and got moisture going between the joints of the flooring. But when it comes to slab on grade and slab below grade, the main source of moisture ends up being the ground. And that's why it's so critical for all concrete slabs that are on ground to receive a moisture sensitive floor covering. We need a vapor retarder directly underneath that concrete so that the ground moisture does not come up and admit into the concrete and then ultimately the adhesive and floor covering. So moisture is a concern for all the flooring manufacturers, and they all recommend testing for moisture, or I should say in most cases they recommend testing for moisture prior to putting adhesive and floor covering down. There's a couple of quantifiable tests that are done quite frequently. This one is calcium chloride testing, where you have a small container of calcium chloride. You weigh that container of calcium chloride for a pre-test weight. You prep the floor, you take the tape and the lid off, and you set this open container of calcium chloride on the floor. You put a double stick tape foam plastic cover over top of the disc, as you see in the right picture, and you tape it down, and you let it go for 3 days, or I should say 60 to 72 hours, which is virtually 3 days. And as excessive moisture emits out of the concrete, it gets absorbed into the calcium chloride, and at the end of the 3-day test, you reweigh that dish, and the difference in weight will equate to literally pounds of water emitting out of a concrete slab, 1,000 square feet of a concrete slab in a 24-hour period. So that's one test method. The other one is relative humidity testing, similar to how we test humidity in a room, testing the ambient humidity in a percentage, from a percentage standpoint. We can do the same with concrete. We can test the concrete for a percentage of moisture. Very commonly, we test it at 40% of the slab thickness, so that when the floor covering is installed and the moisture redistributes in that slab, and it equilibrates, when I say redistributes, it's equilibrating. so that the top, middle, and bottom all end up being the same moisture at that point. But we go into the 40% depth when the slab has no floor covering on it, so that when we do put flooring on it and it equilibrates, we understand what the overall moisture would be, top, middle, and bottom of that slab. So the bottom line is follow floor covering and adhesive manufacturers' recommendations with regard to moisture testing. Many floor covering adhesives now can withstand RH limits between 99 and 100. With the increasing moisture recommendations or tolerances nearly 100% RH, and I call that the race to 100. I swear, everybody's racing to get their recommendation up to 100. As we get so close to 100, it's even more critical now to understand not only RH, but the pH limitations of adhesives. And we're going to spend some time on this now so that we all have a true understanding here. pH is more critical now, than it ever has been, because we are so close to condensed liquid underneath the floor coverings with these high RH limitations. So I told you we were going to come back to efflorescence, and we have done so. Efflorescence is the process of natural salts within the concrete being driven to the surface by excessive moisture. Okay, that whole process of driving the natural salts through the concrete to the surface via moisture is called efflorescence. The natural salts that are in the concrete are sodium, potassium, chlorides, sulfates. There are all natural levels in all standard concrete that really don't harm anything. You look at sodium, potassium, and it's typically 200 to 800 parts per million in a concrete slab, and they don't hurt anything. Your chlorides might be 10 to 100 parts per million. Your sulfates are a little bit higher, maybe 4,000 or 5,000, something like that, parts per million. But they're all in the concrete, top, middle, bottom. They're not hurting anything. However, with excessive moisture, it can drive these salts to the surface. And if we get the condensed liquid, then that condensed liquid can be very alkaline, and then that's what destroys flooring adhesives. So first, I just wanted to make sure we all understand what efflorescence is. Okay, it's a tough word. A lot of people do have trouble with that. I don't want you guys to confuse this with effervescence. I actually wish I had $5 for every time somebody told me they had an effervescence problem with their concrete. It's like, all right, what, concrete has a drinking problem? What? And I've also gotten phosphorescence. I had a guy call me up one time, said, hey, I got a phosphorescent problem with my concrete. I'm like, okay, what, your concrete's glowing? What's going on here? But seriously here, efflorescence, the process of driving those salts through the concrete via excessive moisture. Here's a couple of extreme pictures of efflorescence. On the left, you got VCT, obviously a joint there between two tile, and the excessive moisture has driven the natural salts into the concrete to the point where you have salt formation coming up between the joints. Okay. On the right side, you got floor covering rolled back, and you're looking at the surface of the concrete, and you're seeing a whitish salt on that surface, and that process is called efflorescence, and those are the natural salts within the concrete that have been driven to the surface via moisture. So, efflorescence, these natural salts, they have a high pH. They're very alkaline. We want to spend some time here and make sure everybody understands pH. So we'll start off here with a question. What's pH stand for? And I'm sure you guys all know the answer. Exactly, Planet Hollywood. All right, okay, I'll stick to my day job. Seriously, pH, it's the power or the potential of hydrogen. Okay, this is going back to like 9th grade or 10th grade science. Okay, it's a measure of hydrogen ion activity. And it's quite simply indicating the level of acidity or the level of alkalinity. Okay, that's pH. Now we're going to take it a step further here. But before we do so, I want to make one thing clear. Okay, we're measuring hydrogen ions in solution. Okay, I have solution underlined because that's critical. I want everybody to understand this. We're measuring hydrogen ions in solution. Okay, so maybe you have a swimming pool and you've tested the pH of your water. You can do that because it's water, it's a solution. We can dip the pH tabs in there and we can quickly get a reading on what the pH is of the pool. Okay, we can't test the pH of our pool if we don't have water in it. Yes, that's a joke, but I want you to think about that. I put that in there because we're testing the hydrogen ions that are in solution. Okay, we have to have a solution there to realize the pH. I can't test the pH of my pool if there's no water there. Okay, so keep that in mind. All right, so let's look at the pH scale. Starts from a 0, goes all the way up to the 14. Neutral is 7. Okay, everything to the right of 7, so pH of 8, 9, 10, 11, 12, 13, 14, that's considered alkaline or basic. Everything to the left is considered acidic. Okay, the thing I want you to understand is that this pH scale is a logarithmic scale. Okay, so going from 7 to 8 is 10 times more acidic. Going from 7 to 9 is 100, I'm sorry, I said that wrong. Going from 7 to 8 is 100 times more alkaline. All right, I guess I need a nap. Let me start all over again here. This scale is logarithmic. Going from a 7 to 8 is 10 times more alkaline. Going from a 7 to 9 is 100 times alkaline. Going from 7 is 1,000 times more alkaline. So it kind of puts things into perspective here. Just by going, wow, you may not seem like much, but it's 10 times, going from a 5 is 100 times more acidic. Okay, you get the picture. Let's take a look at some of the things that we're all aware of out there in life. Okay, pure water or our blood, neutral pH. Okay, battery acid, extremely acidic. The hydrochloric acid in our stomach, extremely acidic. Okay, how about Coke or Pepsi? That might be a shocker for some of us. Okay, 2 or 3 on the pH scale. On the other end of the scale, you got bleach, oven cleaner, very alkaline. Drain cleaner, caustic soda, very alkaline. Okay. There's one thing I said that we were going to come back to, and that was calcium carbonate. Something that's used in cements, used in adhesives. Okay. Calcium carbonate is basically limestone. Okay. Calcium carbonate's alkaline. Calcium carbonate is also the active ingredient in Tums, or a generic version of that. If you grab a Tums or grab a generic version of that and look at the ingredient in there, it says calcium carbonate. Okay, we're using that because we have an upset stomach, or maybe some of the acid in our stomach got up into our esophagus, we have heartburn. Okay, the calcium carbonate, the Tums, which is very alkaline, it counteracts the hydrochloric acid. Okay, that's typical pH science. Now you guys are all sitting there thinking, oh my gosh, I can't believe I eat limestone. All right, your typical adhesives out there tolerate a pH of 9 to 10, sometimes 11. Okay, fresh concrete has a pH of 12 to 13. It's very alkaline, but as that concrete cures and the water evaporates and the surface reacts with the carbon dioxide in the air, the surface of the concrete carbonates, and it drops the pH down to about 9 or 10. Totally suitable for flooring and adhesives. So when testing for pH, quite simply, you're a chemist here, preparing a solution. You know, you're cleaning the surface, maybe with sandpaper. You know, you're dripping a little puddle of distilled or deionized water, letting it go for 60 seconds, and you're dropping the paper into it and taking a reading. Again, we're measuring hydrogen ion activity in solution. I can't test the pH of the concrete in this capacity without having the water there. Okay, I want you to remember that. So on to adhesives with high RH values. Let's think about this. If I have an adhesive that has an RH limitation, anything under 100, okay, so even if it's 99, okay, that adhesive is really only to be used on new concrete where the RH will never go any higher. If I have an adhesive that it goes to 99 RH, okay, it only be used on concrete where the RH is not going to go any higher. If I have a building that's 30 years old, it's slab on ground or slab below grade that's on dirt, on ground, you know, may not be any vapor retarder, okay? If we're getting readings, you know, into the 90s, you know, I can tell you that concrete that's 30 years old, it's not water of convenience or the mixed water in that concrete that's giving you a high reading. It's water from the ground that's giving you a high RH. And if that adhesive maxes out at, you know, 95 or even 99, and you're a slab on grade that's 30-year-old building, then you shouldn't be using that adhesive, because the risk is at some point that RH will be higher than the limitation of that adhesive. It could get to 100%. The other thing you got to look at is pH restrictions. Okay, if our adhesive can go to 100%, then we should not have a pH restriction on that adhesive. Because if we get to 100% RH, then we can get the liquid water or some sort of condensed liquid in the concrete. And then with all the natural salts in that concrete, the sodium, the potassium, the chlorides, the sulfates, your pH will rise. And it could be 12, 13, could even be 14. And that's when the adhesive is going to degrade. So if there's an adhesive that goes to 100%, then the pH should be 14. Because if we get to 100% on our RH, then I can guarantee you that the pH is going to be very elevated. The other thing you want to keep in mind is, what does the finished flooring manufacturer state? If the flooring manufacturer says, hey, my flooring is only good to 85 RH, otherwise with higher RH, we get funky things happening to the flooring, then don't use an adhesive with a high RH value. Because the adhesive is just tolerating the moisture. It's not remediating it. Okay, if I have an adhesive that's good to 95 or good to 99, and it's a waterborne acrylic adhesive, then that adhesive is only tolerating the moisture. It's unaffected by the moisture. The moisture can still go through, potentially affect the finished flooring. So my point is, you got to ask the question, okay, what are the flooring manufacturers' limitations with regard to RH? Ask the question. Adhesive back flooring. Okay, there's some adhesives that have a high RH, and these adhesives get sent to a plant for application. Just couple things to keep in mind is just extended lead times, additional shipping and logistics. So if you're using that type of flooring, then just, you know, plan on that, you know, look into that, you know, prior to the job, so that, you know, you can plan for things like that. Again, you know, if the adhesive is suitable for 99 or the adhesive is suitable for 100, you know, is the flooring? Okay, ask the question, what happens to the flooring? Make sure the flooring manufacturer is okay with that. Again, let's look at the pH restrictions. You know, if I have an adhesive back flooring that's 99 or even 100 RH, if we're in an environment where we could get the liquid water or condensed liquid underneath there, then we're going to realize the pH, and it could go to 12, 13, 14. So if we have 100 RH adhesive on the back of the flooring, and the flooring manufacturer's okay with that, make sure the pH isn't an issue, because the pH could go to 12, 13, or 14. Ask the question. Keep it in mind when you're looking at mitigation systems. There's epoxy mitigation systems, epoxy moisture mitigation systems out there. Epoxies have an extremely high bond, much greater typically than adhesives. So something to consider as well. We have high RH adhesive back flooring. If we do get to condensed liquid, ask the question: can mold or mildew, start to grow? I can tell you with the epoxy systems that are out on the market, pick a manufacturer, doesn't matter to me. Those products that were designed to go to 100% RH can handle, 100% condensed liquid underneath there, can handle, 14 pH, and mold and mildew does not grow underneath the epoxy that's bonded to the concrete. Here's a big one that I want all of you to keep in mind. You may have a complete adhesive and flooring system that's suitable for 100 RH and suitable for a 14 on the pH scale. A majority, if not just about all of your patch and leveling products are not suitable for that application. They can't handle being indefinitely wet. They can get wet and dry out and get wet and dry out. But your traditional patch and leveling products are not suitable for constant moisture applications. They have to be developed for that specific application. I know, as an ARDEX representative, a majority of our patch and leveling products aren't good for that application. We have a couple that were specifically designed that can be used in an application where they have condensed liquid or liquid water on them. It can be used outside where it could be indefinite liquid on moisture on it. Okay, you got to make sure you're using the right patching or leveling products. With the adhesive back flooring, tile and plank might be an easy installation. Sheet is very difficult because you're trying to drop a sheet in that has like basically contact adhesive on the underside of it. Okay, and then lastly, as always with any product, read the warranty. Make sure you understand what's covered and what's excluded. I was reading a warranty at one time, and it was suitable for excessive, a high RH will say that, and then in the exclusions it said not suitable for excessive moisture applications. It's like, how can that be? You're recommending this product specifically for high and excessive moisture applications. So always read your warranty documents, no matter what you're looking at. Make sure you know what's covered and what's excluded. All right, moving on to another condition of excessive moisture. This is called slab curl relaxation. Okay, concrete slabs that are placed on ground with a vapor retarder directly below them can experience slab curl due to differential drying. And what I mean by that is the water that's in the top, the middle, and the bottom of that concrete dries differently. The water at the top is drying out of the surface. The water at the bottom can't dry out of the bottom because you got a vapor retarder there. So it has to dry out of the top. So it has to, work its way up to the top and then evaporate out. And during that process, sometimes slabs can curl. And you can quite simply take a straight edge over to a joint and see if that slab is teeter-tottering. And if it is, see if your straight edge is teeter-tottering, which would mean that your slab has curled. And that's what happens. The slab can curl due to differential drying. And like I said, the easy way to check to confirm that that's occurred is take a 4-foot straight edge over to a joint and see if it rocks back or forth or not. And if it's teetering on the joint, then the slab is curled. So that's slab curl, but I want to teach you what slab curl relaxation is and what it can do to an installation. So the easiest way for me to show you this is with a sponge. So concrete is like a wet sponge. When you pour the concrete, it's flat. The wet sponge is totally flat. And we're simulating this, that sponge being wet concrete, and then the vapor tartar in this picture here would basically be the plastic laminate countertop that's underneath the sponge. So that sponge is totally wet. As it starts to dry out, that sponge curls because of differential drying. The water's all evaporating out of the top of the sponge. It doesn't evaporate down, and the sponge curls. So the next thing we did is we put two sponges together, simulating a joint in the concrete, as you see there. The sponges are totally wet, okay, like fresh concrete, and we just let them dry. The moisture evaporates out of the top of the sponge, and when it's all said and done, the sponges curl, just like concrete curls. So what happens is, as you can see down here, at the base of the sub base where the joint of the concrete slabs are, it's curled up off the sub base. The joint at the top where the slabs meet, it's a lot wider open. Okay, so what we do, we put a floor covering on it, and in our little scenario here, it's kind of hard to see, but we put a piece of saran wrap or plastic wrap over top of both sponges. That's simulating a floor covering. And what happens is what moisture is left in the sponge, it will re-equilibrate within the sponge, and then the sponge will relax. And as that moisture re-equilibrates, the sponge relaxes. It's back down on the sub base, which is, in this situation, is the countertop, and the joint is narrowed at the top. And that is what you call slab curl relaxation. So the slab curls due to differential drying, and then when you cover it up with a flooring or epoxy mitigation system or some sort of floor coating, the moisture redistributes, the slab relaxes, and I'm going to show you what the result is of slab curl relaxation. So here you have two slabs, have a saw cut to control the cracking. The concrete slab's curled. The control joint, the saw cut, did what it was supposed to do, and it cracked. But we have the two slabs that are curled off the sub base. So the natural inclination of a flooring contractor is to come in, he puts a straight edge on top of the joint and he sees it's teeter-tottering, so he grinds it flat. And then he takes a patching product and fills the saw cut with a patching material. And then he installs his floor covering. But what happens next is the moisture all redistributes, and then once the moisture redistributes, the slab relaxes, and as it relaxes, it breaks the floor covering right at the joint, and you got failure of the flooring right at the joint. Or, if you have a more flexible flooring like resilient flooring, it can extrude the patch out of that joint and cause a bump in the flooring, just like you see. Here's a picture of a core sample at a control joint that's been patched, and it was, the slab was curled, and we saw a little mole run through the finished resilient flooring that you see up here. And what happened was, basically, as the slab relaxed, the slabs got closer together and extruded the patch from the joint and made a bump in the floor. And this is what you see. Here's some resilient flooring installed, and here's a control joint that after they installed the flooring, the slab relaxed a little and extruded the patching material out, and you see a bump through the flooring. That's a result of slab curl relaxation. On to moisture remediation. There's different methods. You could certainly keep switching out floor covering, although nobody wants to do that. You could try to look at drying the floor with dehumidifiers, but there's no, there's no specification that's saying that, hey, if we use the Binford 5500 moisture eradicator and run it for 7 days, it's going to be suitable to put flooring down. So not really a viable option. There's alternative finishes. You could leave it as bare concrete or stained concrete, put a breathable coating down, but you know what? That might not be what you wanted. You could certainly look at tearing out the slab and pouring new concrete, but that's just not typical. So what's typically done is a liquid applied membrane, 2-component epoxy moisture mitigation systems, very common. For resilient flooring, the specification is F3010. It's for a 2-component resin-based membrane forming moisture mitigation system. These products are 100% solids epoxy very commonly. They're below viscosity. They have very low perm ratings, typically less than 0.10 perms. And you typically prepare the concrete prior to installing them. Very common for remediating moisture. Okay. So looking back on everything that we discussed here today, just a quick summary. Number one, know the type of flooring that's going to be used on a project. Okay. Totally understand that floor covering so that you can choose the correct adhesive for the flooring. Okay. When you're choosing the adhesive, you got to be aware of the RH and pH limitations. Okay. You can certainly test for both to see where you are. Okay. Ensure the readings meet manufacturer's recommendations. And if they don't, you're going to specify a moisture remediation product that's going to correct the moisture prior to installing patch, leveling, flooring, and adhesive. Simple as that. So I want to thank you for participating in our AIA here. We appreciate you taking some time. I'm going to turn it back to Alyssa for a second.
Thank you so much, Seth. That was wonderful. Ton of great information. Really quick before we get into a few questions, I just wanted to throw out a reminder that certificates for today's webinar will be distributed by email. If not this week, by early next week. And if you provided your AIA number of registration, we are going to report your credits from today's presentation on your behalf. So moving on to questions, can you address silicate curing compounds used in construction and their effects on adhesives?
Yeah, absolutely. So there are silicate materials used as curing compounds that are applied to the concrete. And they've been around for 100 years. I mean, literally 100 years they've been around. Some of the early technologies were sodium. They moved to potassium, and some of the newer ones are lithium. You'll typically see that the adhesive manufacturers don't like silicates. And it's not necessarily that they're incompatible, but I do want to explain this real quick so that we have an understanding. What the silicates do is they react with chemicals within the concrete, such as free lime or calcium. And they basically create additional binder that actually binds the concrete. So the main chemical in hydration through the hydration process that binds concrete together is called calcium silicate hydrate. And these silicates react with free lime in the concrete to create additional calcium silicate hydrate. So what they're doing is they're densifying the concrete. Now, there's application. I mean, you certainly have to neutralize and wash so that there's, the results of the chemistry are washed off. There's no silicates left there. So that's critical, and that's within the silicate manufacturer's instructions. But the reason there's so many issues with silicates and adhesives is the flooring contractor does not realize that the density of the concrete is different. The silicates can densify the concrete, they change the absorbency, and they make what's normally a porous concrete a more dense, non-absorbent concrete. So the adhesive may not have the absorption into the concrete, the water from the glue stays in the adhesive, and the adhesive never develops strength. Or maybe a manufacturer okay with going over silicates, but you have to color adhesive notch trowel, and you have to give it a longer open time, maybe a 20-minute open time to let water from the glue go out. So it's a tough situation. The silicates, effectively change the concrete, but not to the point where there's an incompatibility. If they're all applied correctly, it tends to be just we've taken a porous surface and made it non-porous, or even if the adhesive manufacturer is okay with that glue being used, maybe the wrong trowel was used or didn't give it enough open time. Hopefully, it makes sense to everybody.
All right. Another question. When you say that the adhesive is tolerating the moisture, is that to say that 100% relative humidity adhesive may still allow moisture to pass through to the floor covering, but still perform under the conditions?
It's very possible that is a true statement. I would have to look at each adhesive specifically to confirm whether that's true or not. Your typical like acrylic types adhesives that may have a high RH, they typically do not remediate moisture, they just tolerate it. There are urethane adhesives that are a moisture cure material that are used as mitigation systems, and they're put on at such a thick application that they actually do have remediation properties, different from acrylics. So it all depends on the adhesive and the adhesive chemistry. Certainly if you had a specific adhesive, I'd be happy to look at that specific one and kind of talk through whether it's actually remediating or just tolerating.
Great. And
hopefully
then
that helps.
Yeah, and then one more question. We had a ton of questions, I will say. So if we did not get to your question today, either Seth, myself, or one of our sales professionals throughout the country will be answering your questions via email. So the last question is, if a slab has curled, how do you fix the slab so when it relaxes, you don't get a bird bath or a bump?
Yeah, it's an excellent question, and I totally apologize for not even addressing that during the presentation. So, when a flooring contractor goes on site, the first thing he should do when he's looking at slabs with saw cuts is quite simply just go check to see if they're curled. And certainly if they are, it's up to him to raise that red flag. And there's some that that don't curl, or some might be marginal curl, but if we have significant curl to where that straight edge is really rocking, then you can almost bet that when you install flooring or a mitigation system that they're going to relax and we're going to see issues. So in some of those extreme cases like that, what is typically done is they will drill holes in the concrete and they will pump a structural grout to basically fill that void underneath the slab with a structural grout. They'll pump it in, and in essence what you're doing is the slab is curled off the sub base, and we're pumping in a structural grout to fill that void, so that when you do install flooring over it, when you do install mitigation or coating over it, and that moisture redistributes and the slab would try to relax, it can't relax because you have a structural grout underneath of that. Now I'm not saying that that's the answer to every little teeny bit of slab curl that's seen on a job site. Obviously each job site is going to be different. The key thing is if somebody checks that and there is what appears to be slab curl, that they raise the red flag, get the general contractor involved. Maybe there's a structural engineer involved, and the conversations happen. Because the last thing I want to happen is a slab to be curled, the flooring contractor do the installation, it relaxes, and then you see a bump. You see every one of those control joints show through the flooring, and then they think it's something that the flooring contractor did wrong. The reality is it isn't. So those worst case scenarios, we have seen where they drill holes and pump a grout in underneath the concrete to stabilize the concrete so that it can't relax. I hope that helps.
All right. I think that is it for questions for right now. Like I said, if we didn't get to your question, I assure you we will reach out via email and provide you an answer to the question that you submitted. So Seth, if you want to go ahead and quickly go through some of the ARDEX products and Henry products that pertain to everything that we talked about today, that would be great.
Absolutely. I appreciate it. So we'll spend just a little bit of time going through some products here. If my computer wants to comply, I was having trouble with my arrow buttons there. Sorry about that. But we're going to begin with just a few adhesives on the Henry side of the business. I mean, Henry is one of the largest and the oldest adhesive companies in the country. Warner W. Henry back in 1933. Armstrong had owned them from the late 80s through 2000, and we had acquired the Henry company from Armstrong back in 2000. So for the past 20 years, the Henry brand of adhesives is under the ARDEX umbrella. We basically have 8 key adhesives or 8 elite adhesives. Wide variety here. Some of the newer technologies for us, Henry 647, we'll spend a few minutes on that, but it's a LVT, LVP, and sheet vinyl roll-on pressure-sensitive adhesive, high RH. We have 695 that's both pressure-sensitive and wet set, high RH. We have 650, which is a releasable carpet tile adhesive. 430 is a clear thin spread for the installation of VCT. Our carpet adhesive is called Henry 351. We have a dual purpose or a multi-purpose called 256. That's for felt back sheet vinyl and carpet. We have an acrylic / urethane waterborne extremely high solids wood adhesive called 1171. And then the industry standard for cove-based adhesive, Henry 440, been around for many, many years. We do have some adhesives that fall into that high RH category, and I want to make sure that everybody is on the same page as to what we recommend. The 647 and 695 are at 99 RH, 430 and 650 are at 95, and you will see that they have a pH of 11. The critical thing here is if we do not use any of these adhesives in an environment that would be allowed to get to condensed liquid or liquid water in the slab, because if we get to that point where we're at 100 RH in liquid water, we're going to realize a pH of 12, 13, 14, and just like all the other adhesives out there that might be high RH and have a limit on pH, failure is going to occur. So for slabs that are above grade and we have no other sources of moisture other than the water, then yeah, we could do that above 8 if we're reading 90, and all of our other site conditions are such that we see that RH today being 99, but next week being 98 and slowly going down, then it's perfect for those type of adhesives, and they'll tolerate that RH. They're tolerating it. They will go on and perform unaffected. Couple of things. If we're on grade, it's critical that we have an effective and an intact vapor retarder. If we have a slab that's 20 years old and we're reading high RH, we don't use any of these Henry adhesives nor any similar adhesives out there, because a 20-year-old slab is not having excessive moisture due to water in the concrete. That's ground moisture at that point. And if we're reading 95 or 98 today, it's very possible we could get to 100, and then you're outside of the parameters of the glue and you're guaranteed for failure. So, we stay away from those applications. And the second criteria is we have to comply with any limitation posed by the flooring manufacturer. So even though my adhesive goes to 99 or goes to 95, if the flooring manufacturer says 85 is the max for the flooring, we can't proceed with the adhesives because they just tolerate adhesive. And if we have issues with the flooring, then where are we? Then I'm saying, hey, my glue isn't affected, but the flooring is, and it's a failure. Nobody wants a failure. Okay, so yes, we have high RH adhesives, but we qualify where they're used to ensure that we don't have failures in the floor covering itself. Couple of the glues, 695. Okay, this is a wet set or pressure sensitive. When you go to pressure sensitive, you got a really long working time, 4 hours, up to 99 RH. Okay, excellent bond strength, and this product's trial applied. Okay, its counterpart, similar technology but not quite the same, is called 647 Plum Pro. You'll notice in the picture that it has a color to it. I call that lavender, but some people back at corporate think that's plum. But hey, to each its own. I guess Plum Pro sounds a little bit better than Lavender Pro. Okay, I'll shut up and stick to my day job. But we pigment it on purpose. That's the bottom line. This is a roll-on adhesive that's very easy to see where you're going and where you've been. Also, it transitions from a light plum to a dark plum when it goes from wet to dry. So it's very easy to understand when it's dry. It goes dry to the touch, and then you drop the flooring in. And it can literally be a matter of minutes that this goes dry to the touch. Very high solids material. And you can drop, tile, plank, sheet into this and presume traffic immediately after it's done. You open it up to traffic. So it's a pretty key attribute. It's suitable for 99 RH. Excellent material. Another good one of ours that does very well is 650R. This is a pressure sensitive adhesive for vinyl back carpet tile. You apply the adhesive, you let it go dry to the touch, but it's releasable. It's not permanent. Okay, it's permanent in the regard that your cushion back vinyl and your carpet tile totally perform in a pressure sensitive releasable application. But we're only stopping movement laterally, left, right, front, back, okay, which is totally fine. The beauty of it is you come back and you want to replace some carpet tile 2 years from now, you peel the carpet tile back, the adhesive's still tacky, you drop new carpet tile in, the flooring performs, okay. Also ideal for the glass back sheet and installation. So the real thin, flexible, pliable glass back sheet products. The key thing here is we only recommend it in a pressure sensitive recommendation when the flooring manufacturer recommends a pressure sensitive releasable application. Okay, very critical. We have some high RH subfloor preparation products, namely a family of moisture control products. MC Rapid, I mentioned ASTM F3010. That was the moisture mitigation material industry standard for resilient flooring and remediating moisture. MC Rapid meets that standard. It's for 100% RH, can be used on grade, below grade, pH of 14. Doesn't matter if we get the condensed liquid or high pH. Sorry, I'm having presentation problems here. It's advancing on its own. But MC Rapid is your application for remediating moisture in a renovation application, on grade, below grade. We even use this on new concrete after days after being poured as a part of our ARDEX concrete management system, where we install MC and leveling products on concrete that's a matter of days old. We have two step-down products, one VR98, which is a waterborne acrylic, and the other one is called PU50, which is a moisture-cured urethane. So similar to the adhesive technologies where you have a waterborne acrylic or a moisture-cured urethane, these products are moisture remediation materials up to 98% RH. They truly do remediate. They have very low perm ratings, and they are unaffected by pH. So if we get to a pH of 14, these products are unaffected. And I apologize, but now my presentation continues to advance on its own, so my apologies. We have a full line of leveling products. You guys probably know ARDEX from the leveling standpoint, K15, dating back to the early 70s. late 70s when we introduced it here in the North America. We have a variety of different products in the self-leveling lineup, from entry-level V1000 all the way up to the Cadillac K15. We have a couple of specialty products too, K60 and K22F, that we'll kind of review here too. So K13, this is a dual water product. You can do standard mix ratio or a higher water mix ratio, whether you want standard flow or high flow. Pretty cool technology from that standpoint. All of these underlayments go up to 99% RH, and they're totally unaffected. They tolerate moisture up to 99. If we get the condensed liquid, these products, as do many, just about every other product out there in the industry, they will be affected by liquid water or condensed liquid on here. We will mention a couple of products that are unaffected by liquid water. From there, we go to our workhorse. This is V1200. Floor covering over this in as little as 24 hours. Pretty versatile, all the different types of substrates, and can virtually go up to any thickness with this material. The V1200 is what we commonly see used out there in the industry from a leveling standpoint. That is our workhorse. The K60 is a product and a technology that comes from ARDEX UK. Original formulas of this product date back to the late 70s. It's certainly been improved along the way. But the cool thing about it is it's mixed with a latex additive. You're not mixing it with water. One bag with a gallon of latex. Simple as that. It sticks to pretty much anything, to include porcelain tile with no additive in it. With no primer to be used. You know, the additive that's mixed in with the K60 gives you that chemical bond to a surface like porcelain tile. The K60, we can use this under mitigation system because it can handle 100 RH. We'll use this to pre-level or pre-smooth under MC Rapid. And it doesn't matter if we get to liquid water, condensed liquid underneath there on the K60. It doesn't matter if we get the pH of 14. K60 is unaffected. I want to let you know that we have a variety of different patching and leveling, different patching materials out there on the market, from unsanded products like feather finish to rampable products like SDP. But the one that I really want to focus on today is MRF. It's the cousin to K60 in the regard that it can go to 100 RH liquid water. So this is kind of the 1-2 punch. MRF and K60 as 100% RH products. They can be used under moisture mitigation systems. They can be indefinitely damp with liquid water or condensed liquid. They can handle a pH of 14 with no adverse effect. I mean, MRF could be used outside for that matter, just to paint the picture for you. So when you're using, maybe a floor covering that goes to 100 RH, or an adhesive that goes to 100 RH, and there's patching required, you need to use a skim coat product like MRF, or you need to use a leveling product like K60, because if we get to 100% RH, high pH underneath that flooring structure, we want to make sure that the patch or leveling material is unaffected, just like the adhesive and flooring would be unaffected. So keep that in mind, everyone. The last thing, one of the last things I want to mention here is our System 1 warranty. When we acquired W.W. Henry back in 2000, we found out that Henry had some of the most comprehensive and diverse adhesive warranties out there in the industry. 10-year warranted products, bottom to top, top to bottom, materials, reasonable labor. And what we did is we took select Henry adhesives and select ARDEX patching and leveling products and created System 1. So by using select Henry adhesives, select ARDEX products, there are System 1 warranties out there that go to 20 years, adhesive, patch, and leveling. And that's not a prorated warranty. It's not a material replacement warranty. If there's a defect in the adhesive or a defect in the patch or leveling product, it is a replacement of all products: flooring, adhesive, patch and leveling material, and reasonable labor. to repair that area or replace that area, depending on what the condition is at hand. So I want everybody to understand that System 1 warranty. Have a look at our website if you want to see all the details. Shows you exactly what it includes and what maybe it excludes. Very comprehensive warranty. Lastly, I just want to mention one last thing. In addition to our substrate prep family of products, our moisture control products, our adhesive family of products, we have 3 other families of products here. Concrete repair, we have decorative or cosmetic concrete repair products for redoing driveways and sidewalks. We have structural products too for repairing, brick, parking garages, structural stamp. We have a full line of waterproof membranes to specialty membranes to especially thin set mortars and route materials, full line. And when the ironic thing about this, when you look at ARDEX from a North American standpoint, everybody pretty much knows ARDEX Americas as the patch and leveling company. When you look at ARDEX as a global company, there's some 50 ARDEX companies around the globe. We're truly, known as a tile and stone company when you look at the volume of products that we sell global. So we have some awesome technologies on the tile and stone side of our business. And then finally, we have a complete line of finished surface products, from trowelable products to self-leveling products. Products get sealed with acrylics, epoxies, urethanes, products that get polished as decorative polished toppings, both trowelable and self-leveling. Integrally colors, topical stain, decorative saw cuts, fancy logos, complete line of finished surface products that date back into the early 90s, early to mid 90s, that we were doing, us along with our contractors, doing all these different decorative types of applications. So pretty cool stuff in that line of products. But just wanted to let you know the versatility of all of our different product lines. Finally, I'd like to again thank you for your time, and just to reiterate, what Alyssa said a little bit earlier, we got 3 more of these these AIA webinars coming up in the near future. Designing installation systems for gauged porcelain tile panels. These are the meter by 3 meter porcelain panels. We have a Q&A session with Peter Craig. If you don't know Peter Craig in the industry, I mean, he's an expert in concrete, expert in moisture. He supported ACI and ASTM for years and years and years, and chaired different committees and associations. So that is a worthwhile webinar coming up. And then wrapping it up, I'm going to be conducting a basic proper prep webinar, how to prepare all the different substrates out there, the concrete, the metal, the ceramic, the quarry tile, the porcelain, existing coatings, how to prepare all those surfaces to receive patching and leveling materials. And we'll talk a little bit about cracks and joints in concrete in that presentation as well. So again, my name is the technical of ARDEX. On behalf of myself, Alyssa, and ARDEX, we certainly appreciate the time you've given us here this afternoon. If we can help you out in any way, by all means, reach out to us. Thanks again, everybody.
Thanks, Seth. Everyone have a great day.
Take care.